Hello students, welcome to Decluttered. Today we'll be looking at question 6 from the JEE Advanced 2025 paper 1 mathematics section. This is a very interesting problem on functions. So pause the video and do give it a try. Alright, let's get to cracking this problem. First, it is given that n denotes the set of natural numbers and z denotes the set of all integers. And we have been given two functions, f from n to z and g from z to n. Alright, now let's look at f of n first. F of n is given as n plus 1 by 2 if n is an odd natural number and 4 minus n by 2 if n is an even natural number. So let's try and quickly plot f of n. So here is my y axis and here is my x axis. So I'll denote this as n and this will be my f of n. So first let's only look at the odd natural numbers 1, 3, 5 and so on. First, if I substitute n equal to 1, then I will get 1 plus 1 by 2 which is just 1. So let's say somewhere here 1. Next, if I substitute 3 plus 1 by 2 which is 2. So next I'll get 2 somewhere here. Next, for n equal to 5 plus 1 by 2 which is 3. So 3. So as you go through the odd numbers one by one, the value of the function f of n will be all the positive integers one by one. Therefore, for n equal to odd, the output is all the positive integers. Alright. Now let's look at n equal to even case. If I substitute n equal to 2, first, so 4 minus 2 by 2 which is 2 by 2 or 1. So here also I am getting the value as 1. Next, for n equal to 4 minus 4 by 2 will become 0. So here. And next, n equal to 6, we will obtain 4 minus 6 by 2 which is minus 1. So somewhere let's say here minus 1. So for convenience sake, I will draw a line like this just to show that at each odd value we are getting positive integers. For each even value we are first getting 1, then 0, then minus 1, and it will in fact go through all the negative integers. So that means for n equal to even, in first case n equal to 2 will get 1, n equal to 4 will get 0, and then n equal to 6, 8 and so on, we will get all the negative integers. So this tells us that f of n will take all the integral values from minus infinity to plus infinity. So which means f of n is onto as the codomain of f, that is z, is also the range of f. Now next let's look at 1 nature. So here you can see that f of 1 is equal to 1 and also f of 2 is equal to 1. So because f of 1 equal to f of 2 equal to 1, f is not 1 1. Alright. So this means that option D is correct. Alright. Next let's look at g of n. So the input for g of n is all the integers and the output is natural numbers. So let's look at the case where n is greater than equal to 0. So at n equal to 0, the value here will be 3. Alright. Next, at n equal to 1, the value will be 5. Then at n equal to 2, the value will be 7. So as you can see, if I take any positive integral value of n, then I will get all the odd values on this side. This will become important as we'll see later. So we can just say that f of n will give odd values for n greater than 0 equal to 0, but it won't give 1. Alright, now let's look at the negative part where f g of n is minus 2n if n is less than 0. So we have to start at n equal to minus 1. For n equal to minus 1, we get the value as 2, let's say here. Then for n equal to minus 2, we get the value as 4. And then so on. If we continue, we'll get all the even values of g of n. So that is g of n will give even values always for n less than 0. Alright. So now when we look at this, it suggests that g of n cannot take the value 1, but it can take all odd values for n greater than 0, and it's only taking even values for n less than 0. So from this, g of n is not onto, as it cannot take the value 1, which is a part of the codomain n. But we can say that g of n is 1 1, as there are no two distinct values of n are giving the same output. Hence, we can say that this option is wrong. Alright, now let's move on to the first option, which says g of f, that is g composition f or g of f of n, is not 1 1 and not onto. So we have g of n as 1 1 but not onto, and we have f of n as not 1 1 but onto. Alright, so now let's look at g of f of n. So this function will be defined from the domain of f, which from here is n, and its output will be the codomain of g, which is again n. So that means this function is defined on n to n. Alright, now let's look at this. F of n is not 1 1. So the issue was coming at n equal to 1 and n equal to 2, where the value of f of n is 1. So therefore, if for g of f of n I substitute n equal to 1, I get g of f of n equal to g of f of 1, which is equal to g of 1, which from here it is 5, equal to 5. If I substitute n equal to 2, then my g of f of n will be equal to g of f of 2, which again is g of 1. Why? Because from here f of 2 is also equal to 1. Therefore, we get the value as 5. So this shows that g of f of n is not 1 1, not 1 1. Additionally, one more thing that we can see is that g of n is not onto. Now, if g of n is not onto, that is, it is not able to take all the natural numbers, then obviously g of f of n will also not be 1 1, because there is no value of the argument here that can give the value as 1, right? Because that is what was missing from g of n. Therefore, we can conclude that g of n is also not onto. Right? So option A is correct. Next, let's move on to option B. For f of g of n, we had f of n as n plus 1 by 2 for n equal to odd, and 4 minus n by 2 if n was even. So, and our g of n is 3 plus 2n for n greater than equal to 0 and minus 2n for n less than 0. Now, what we can see is that for n greater than equal to 0, the value is always odd, but it's never equal to 1. And for n less than 0, the value is always even. So what we can do is instead directly substitute these functions into here for the specific case. So we get f of g of n as equal to substituting 3 plus 2n for this case, we get 3 plus 2n plus 1 by 2 for n greater than equal to 0, which comes out to be n plus 2 for n greater than equal to 0. And for the case of even out, for the case n less than 0, we have 4 minus of minus 2n by 2 n less than 0, which gives us again n plus 2 for n less than 0. So it can be seen that the function f of g of n is n plus 2 for all the integers. So hence this plot will just look something like this, where it will be taking all the integral values from minus infinity to plus infinity along the line n plus 2. So that means f of g of n is onto, as the function is defined on z to z. Also, f of g of n will be 1 1. Why? Because it is taking the same function n plus 2 everywhere, which will not have any same value at all for different value of n. Hence, f of g of n is onto as well as 1 1. But here f of g is given as not 1 1, so this option is also wrong. Hence, the answer to this question are option A and D. Hope you liked our solution. If you did, please don't forget to like, share and subscribe to the channel. Thank you.